this stretch we have to cover T2 to T problems so that P to T common inter will be completed entire analysis. So let us start with a beautiful question now. Very interesting question. I'm going to start first. It's a T2 question. We'll try to complete. T2 is a very interesting question for me because we need some trick for this question. The trick we'll see. This is Vi. We have a transistor. This is 3.9K. This is 12 volts. We have 220K. This is a capacitor to output. Beta is 120. R0 is infinite. VB is 0.7. He's asking you what is the input impedance. He's asking one question is what is the input impedance and what is the gain. What is the gain of the system? So two questions he's asking. Why I said this question is interesting for me to teach in the class is this biasing, if you see in DC analysis we have studied collector to base biasing circuit. This will create some problem for the student in AC analysis. That problem, how to resolve it, what is the trick behind that? We'll try to see in this question. If it's a fixed bias, we don't have any problem. AC analysis is easy. If it's a fixed bias with emitter feedback, we don't have any problem. Voltage diode bias, we don't have any problem. But whenever this type of biasing comes, there will be some inconvenience for the student to solve this. So what is that inconvenience will come and how I do this problem? Try to see the methodology. If I write for this AC model, suppose for this AC model if I'm writing, it looks like this. It looks like this. There will be some R pi. Can have a R pi. Next we can have a current source. Gm into V pi. Next we have is 3.9K. This is your output. This is your input. Up to here this model is completed. Just only the problem here is you are getting from this point to this point. One resistor is connected like this. This is 220K. So this is the problem coming in this biasing circuit. In previous problems we don't have that contact. But in this type of biasing, collector to base biasing in AC model, it will connect from input to output. So that is called a special quotient in amplifiers. So whenever any resistance or impedances comes in contact from input to output, we call this as a feedback resistance. So I told you one trick for this. Whenever you have feedback resistance, don't see like that. Use Miller's theorem I said. So if it is a 220K, this is input to output. You have the contact. This is looking like a feedback. This is looking like a feedback resistance. Whenever there is a feedback like this, we can use a technique called Miller's theorem I said. So these problems can be done by Miller's theorem approach. Apply the Miller's theorem for this. Okay. Whenever Miller's theorem is applied, this model conveniently will come like this. That is 220K by 1 minus AV parallel to R pi. Next you can resolve it to Gm into V pi parallel to here 220K by 1 minus 1 by AV and finally here RC that is 3.9K. This is your output. So can you see the beautiness of this theorem? What simplicity I have done is just I cut this resistor into two parts by using Miller's theorem. Okay, that is the specialty of this type of questions. Whenever collector to base biasing problems comes, this is the way how I do the problems. Using Miller's theorem I solve it. What is the formula I said in Miller's theorem is Z1 should be Z by 1 minus AV. This is the formula. And the second formula is Z2 is equal to Z by 1 minus 1 by AV. So these formulas we can apply it. Yesterday class we applied for capacitances. Now we are applying for resistance. So wherever you want you can apply this contact concept. So this is the beautiness how it became a normal situation again. Previously it is in contact. Now it became a normal amplifier model. So the trick you must be able to understand. Okay. So now can you expect AV is unknown. Here AV is unknown in the class. If you want AV, this AV what we'll do is we'll neglect it. Because open loop gain is AV. That AV is not closed loop gain, it's open loop gain. Open loop gain is always high. So we'll assume that 1 by AV is neglected at the final stage. So only take here, as AV is high, generally AV is high, which is an open loop gain. AV means open loop gain is always high. So that's why 1 by AV you just neglect it. Then what is the formula here? About open loop gain formula is minus Gm into RC parallel to what is this 220K. Just apply the bypass gain. It's a bypass amplifier. So minus Gm into RC parallel to 220K will come. So 220K with RC minus Gm into 3.9K is your RC parallel to 220K. So completed your gain answer. Gain we can solve like this. But the problem here is Gm we have to find out. So Gm will always come from biasing circuit because Gm formula is ICQ divided by VT. So it will come from DC analysis. So you have to do some DC analysis to get that ICQ. Then you can find it. Okay. So this is the style how we will find out the gain problems. So Gm if you want to find you need the operating current. If you want operating current first you have to go for DC model. These questions we know how to do DC questions. DC question is not a matter I am thinking. If you write a DC model, it looks like a collector to base bias circuit. We have done all these problems in previous class, so no problem. This is 12 volts. This is 220K. This is short. So this current is IB plus IC. This current will be IC. This current will be IB. This point is 0.7. So like this we have the DC model. If you are good enough in DC analysis, I think finding IC current is not impossible there. So first IB current if you solve here, 12 minus 0.7 divided by 220K plus 1 plus beta. 1 plus beta. Beta given in the problem is 120. 120 into 3.9K. So like this you can solve your IB current first. KVL I applied, you can find out the IB current first. Okay, IB afterwards, IC you can solve it. So IB current we are getting around 0.0163 milliamperes. So according to my data, we are getting it as 0.0163 milliamps. Then IC, if you want then IE current, it will be 1 plus beta times of IB current you can solve. IE or IB, anything you can solve, IC, IE is 1 plus beta times of IB. So 1 plus beta is 1 plus 120. Beta is 120 I think, into IB current, 0.0163 milliamps. So just you can solve this current, IE current. Is coming to be 1.97 milliamperes. So this is the way how to find operating current. IEQ current is coming around 1.97 milliamps. Here IEQ or ICQ both are same. If you want IEQ you can write IEQ. So it is around Then GM, finish off the problem. GM is equal to 1.97 milliamperes divided by VD. I think the problem is specified as 26 millivolts. If you say 26 millivolts, you have to take only 26. Okay. If they say 25, you have to take 25. If they don't say anything, I'll take 25. So GM you can find out. Otherwise, you can make a reverse answer. RE you can find 26 millivolts by 1.97 milliamps. You can find reverse answer also if you want. RE is 1 by GM. RE is 1 by GM. So RE value is coming around 13.15 ohms. So RE will come like this. 13.15 ohms is coming. So what is the gain formula now? AV is equal to minus 3.9K parallel to 220K divided by RE 13.15 you can write. So this is the gain answer. This is the gain answer. We are getting around minus 291.41. So this is the gain calculation. So only the time taking process for you is this DC analysis here. Then gain automatically you can find out. Yes, Swati, you can do it. IC is equal to beta IB also you can do it, no problem. 1 plus beta also no problem. Both will give the same answers, don't worry. Approximately same. And Ananya is asking how many questions are left. A good number of questions are left. Okay. Nearly around 15 questions I think we have to solve. By 4:30 we'll finish the story. Each and every question I'm solving. Let's see. So AVS minus 291.41 is a very interesting question. Most of the students will feel of this question. Try to see the procedure for this. And what is the input impedance? If anybody asks, you know, input impedance. You are calculating the input impedance from here. Then these two are parallel to each other. So you can write it as 220K by 1 plus will come 291.41. Just whatever the gain you got, you keep here, it will become 1 plus AV. Okay? 291.4, whatever the result you got, you keep here, that will become parallel to beta RE. Alpha is nothing but beta RE. Okay? Because RE already known to us, so beta RE you find out. So this answer, please calculate. I think according to my answer, it is 509.4 we are getting. 9.4 ohms. So like this, this person will solve this type of problems. Maximum this question comes for 2 marks. Okay? This is a special topic called collective two-phase biasing concept. So you can take this idea. This completed the story about the question. So the option, according to this question, option D is matching for this question. Option D will be the correct answer for it. Option D is correct answer. Parallelly note on it. Otherwise, so you can just listen to the class. Afterwards, you can copy it. Let me complete one by one faster. So can you agree with this procedure and answer? If you agree this T3, T4, T5, T6, 4 questions are the simple questions. We'll finish up. Okay? Other 4 questions are simple questions. Formula-based questions are there. Let us complete it. So you try to solve the T3 question here. T3 is a direct question, formula-based question. And see that what is the answer for the T3. T3. Here, don't worry. Here we can take this answer. ICQ is equal to beta IB. Answer will not change much. Anything you can take. Because beta is 120 given, so beta is very high, so answer will not deviate much. Okay? If they give options wise, you can go for the trick. Approximate tricks you can apply. But if the fill in the blank is given exact way, you have to solve the question. Okay? It is better to go for exact if the fill in the blanks are there. If the options wise, you can go for approximate or exact, whatever you like, you can do it. So let us understand the T3 question now. T3 question. He has given here, he has given RL value. RL is 10 kilo ohms. HIE he has given as 1 kilo ohm. HFE he has given as 50. HRE he has given as 0. 1 by HOE he has given as 40K. And he's asking you what is the voltage gain, how much? So you have read already hybrid parameter models. Okay? Can you see clearly here HRE is 0 but HOE is not 0. That means okay, exact calculations we have to do because HRE is 0 but HOE is there. Means one parameter will affect in the problem. The gain formula here is, the gain formula we have studied is current gain into load by input impedance. This formula is the standard formula for two-port networks. From the two-port network theory, our formula came like this. Current gain into load resistance divided by input resistance. According to current gain, if you see exact formula, it is minus HFE divided by 1 plus HOE into RL. If you see correctly, we cannot take approximate answer here. We have to take exact answer because HOE is given in the problem. Okay? That's why we have to go for standard formulas in the class. In the first classes I told you, okay, remembrance of this 4 formulas are very important sometimes, like this. If you don't know this answer, I think this problem you can't solve. So that is the exact formula. Minus HFE divided by 1 plus HOE into RL. This one formula should have a standard practice. So it will be minus 50 by 1 plus HOE becomes 1 by 40K into load is 10K. This becomes 4. This is minus 50 into 4 by 5. Okay? This is 50. This is 10 times. So it is minus 40. We are getting current gain. Current gain is coming minus 40. Then what is the formula here is AV is equal to minus 40 into what is that load is 10K divided by ZI. Exact answer is ZI answer is HIE plus HRE into AI into RL. Actually this is the complete answer. But in this question he made it simple for you. HRE he made 0. So this term can be neglected. So only you can write HIE in the problem. So the gain will be, it is minus 400K divided by HIE is given as 1 kilo. So it is coming to be minus 400 is, answer is coming to be minus 400. So B will be the correct answer for this option. So you can see how the question's pattern will be. So it is not important is not correct. That formula should be in practice always. Okay? Only 2 formulas. This AI and ZI to find out this type of problems. So answer is coming here, minus 400 will be the correct answer for this. It's a very simple question, formula based question. T4 we'll try to see what is asking. T4. T4 question एक बार try करो. A common emitter amplifier has an unbypassed emitter resistance of 0.5 k and collector is 5 k. Beta of the transistor is 100 and is opening at 1 milliampere. What is the voltage gain of the stage at mid band? So your formula for common emitter unbypassed you require. So next problem if you see, T4 is talking about common emitter unbypassed. Common emitter unbypassed. For common emitter unbypassed, the formula for the gain is minus Gm times of Rc divided by 1 plus Gm times of Re. Standard formula. Number of times we have done this formula. Minus Gm into Rc by 1 plus Gm into Re. Only thing is Gm is unknown. Everything we know. But he has given in the problem operating current 1 milliampere. So Gm you can easily solve by operating current by Vt. This is the formula. ICQ is 1 milliampere divided by Vt. The problem not given, so you can take 25 millivolts. It will become 1 by 25 ampere per volt. Okay. So you can write gain formula. You can solve it. It is minus 1 by 25 into Rc given in the problem is 5k divided by 1 plus 1 by 25 into 0.5k. You can just solve this problem by this formula technique. How much is coming? Just solve it. So calculate this answer. T4, what is the option for this? He has given 200 one option, 100 is another option, 10 is another 50. What is your answer? Please try to solve this, calculate. So please give the answers here. T4, how much you are expecting? So I'm waiting for your message. Please complete it and tell me the answer. Meanwhile, T5 question will solve. Given data here is VCE is equal to 5 volts he has given. IC is 100 microamps. Current gain beta is 100. The input resistance of the circuit for common emitter is nothing but simply R pi. For any common emitter, input impedance will be R pi. Okay. Shaw is telling 200. I think the answer will be 10 will come. Thank you. The answer you can expect 10. So minus 10 actually. In the options he has given magnitude I think. That's why you can take 10. In magnitude it is 10. 10 is the correct answer. Yeah, great. So if you see this one, T5 question is asking input impedance of common emitter. It is R pi is the input impedance. R pi can be written as simply beta times of Re. Beta times of Vt by Ic. So it's a simple problem. Beta Re. Ic is given already. Beta is given. So 100 into beta is 100. Vt in the problem. Vt. Vt how much? It has not given Vt. So you can take 25 millivolts by 100 microamps. You can solve this answer. You can solve this question. It's coming to be around 25 kilo ohms. Suppose in EC book, suppose you are not seeing this question, you practice in electrical book. Okay? By chance, 1 or 2 questions may miss in electrical to EC book. Or miss all the questions, you take it separately and practice that questions. Maximum questions are same, both the chapters, but some extra questions are there in electrical rather than EC book. That's why I'm solving electrical book. Extra questions I'm seeing in electrical, not in EC book. So T5 is coming around 25k. T6 will be the final question for you. The last question, T6. T6 question you can see, he has given HIE is equal to 1 kilo ohm. HIE, HFE is given as 30. It's ohms wrong here, it's only 30. HRE is approximately 0. HOE is 20 into 10 power minus 6. And RL is equal to 2.5k. This is the data given in the problem. So it's asking you, calculate the voltage gain, AV and T, power of your transistor. So AV and TT you want to solve. If you want AV, AI into load by Zi, same style. But AI will come from minus HFE by 1 plus HOE into RL by Zi is HIE into RL. Just now only we solved somewhere this type of problem. So exact because HOE is given in the problem. So let us finish that problem. So thus, if they don't give anything, common emitter bypass or unbypass, suppose they are not given. Total logic use karo. Capital R is not given in the problem. If capital R is given, it will become unbypass. If capital R is not given, it is becoming bypass. Okay, try to understand the logic. If you want to give a question to me, unbypass, RE you have to give to me. RE nahi de rahe, then why you are feeling about unbypass? ऐसे think करो यार. थोड़ा logically think करो subject को. So this problem you can solve it. With this formula you can solve it. I think it's coming to be around 75 something is coming. 75. If you solve it, and the power gain, power of your transistor is AV into AI. AI already we are solving here. These two things if you solve, it comes to be around 2250. Approximately you get this answer. So this is the way how to solve it. Suresh Kumar, this total answer current gain is positive, but this negative y kept means for voltage gain. Okay, for voltage gain we have a negative sign there. So minus of current gain का value negative, first y I'll apply negative means to make it as a phase shift amplifier there. Originally current gain is positive only, but the negative sign is an indication coming for the voltage gain analysis. So you have to write that minus due to the reason of that it has to carry forward to the voltage gain in the calculation. Generally current gain will be positive. Okay, in common emitter current gain is positive, but result you have to write as minus HFE in the formula. The only reason is the voltage gain should become 180 degrees phase shift with that sign. The negative sign indicates for voltage gain it has to come as 180 degrees phase shift, not for current gain, for voltage gain. Due to that reason we'll keep AI with the negative sign. Okay, so I think we are Chapter number 7. Just first I'll write the questions. I think questions numbers is not required. Straightforward, you can solve. Chapter number 7. About the concept of common source amplifier we are studying. Whatever the question is related to common source, we can solve the questions. I'll write the question numbers otherwise. Which questions you can do is in chapter number 7. In the order of electrical book I'm writing. Based on electrical book. Question 1 we can solve. Question 2 we can solve. Question 3. Question 5. Question 6 we can solve. Question 7. Question 8. Question 9. Question 10. Question 11 we can solve. Question 12. Question 13. 14. 15. 16. These all questions are related to common source. Question number 19. Sorry, question number 17. Question number 18. Question number 19. T1 already we done. T2 हो गया. T3 and T5. These questions I have to cover in MOSFET. If you can cover these questions today class will be over. 4, 5, 6, 7, 8, 9, 10. 6, 7, 8, 9. Nearly 20 questions are there. In MOSFET we have a good practice. 20 questions you can get for only common source amplifiers. So all the questions will be covered in the workbook. So why can't you have a good practice of workbook is more important rather than any books you study. Okay? Because I'm seeing all different questions in the concept. Let us investigate one by one and you can check your answers related to my procedure, what I'm doing. So this will be the background notes for you. You can solve it whenever you want. Suresh Kumar, here don't confuse here. Don't confuse. Current gain is actually called beta, actually. We never write minus beta, we write as beta only. But in the problems what happened is, you have gone to two-port network theory. Because of two-port network theory, my current gain I have to take I1 to IL. But we have taken negative sign because I2 is coming opposite to me. That sign is not due to current gain sign. That sign is due to two-port network sign. Understood? That is the reason generally the formula has prepared like that. It is created as minus HFE by 1 plus HOE into RL. But beta is positive only here. So this sign is confusing for the student. That sign is not meant for current gain. That sign is due to two-port network sign. And that sign, if it is there only, in voltage gain formula, you get 180 degrees phase shift. Otherwise, if the sign, if you miss, it will become positive gain and it will become wrong in the concept. So don't get confused. Current gain formula, you write with a sign like this. You solve it, the problem, with a negative sign only, you solve it in exams. Okay? If the question is asked in magnitude, you write magnitude answer. If the question is asked with a sign, you just write with sign that answer. Okay? After that, voltage gain will become automatically negative, so that it will be 180 degrees phase shift. Like that. Really speaking, current gain is not negative. Actually, our style is like this. This is I1, this is IL. This is our current gain technique. But how you have been explaining two-port network theory is like this. When you are teaching like this, oppositely, the sign will come definitely current gain. But if you teach correctly I1 to IL, then you will get no negative sign will come there. So two-port network is sign here. Okay? Originally, current gain will be always positive in the common emitter amplifier. That one please try to understand. So don't get confused. Formula wise you do it. That's a house sign, you apply sign and solve it. No need of telling to the people that current gain sign negative or positive is any baat karna. Chalo then we'll start one by one questions. Our game starts with the question number 1. Question 1, nicely you can see one by one each question, how simple they are. Each question ka analysis ho jayega. He has given some common data question with only one circuit with common data. He is like this, 2 mega ohms. This is an A2 battery, 2 volts. This is MOSFET, JFET. Sorry, it's a JFET given. This is 20 volts. This is 2 kilo ohms. This is your output. This is your input. First of all, tell me, the circuit name is what? It's a common source bypass or unbypass. First recollect it. The circuit name is common source bypass or unbypass. Yes, Suresh Kumar, current gain will be always positive. Because of two-port network calculations, the answer will come negative value. Okay? Yeah, I'm expecting by 4 o'clock we can finish up. Okay? So 5 o'clock I think you have some schedule. So 1 hour you can have a break. 5 o'clock you can attend the network theory. By 4 I'll complete the task. 4 o'clock ho jayega aaj ka class, try to see. So this is the circuit. What is the circuit name here? Very good. It is a common source bypass. Now can you tell me what is this biasing circuit? What is this biasing circuit? You are giving some minus VGG battery. If you give minus VGG, we have 3 biasings I told you. One is fixed bias, one is cell bias, one is voltage divided bias. By seeing this you have to tell minus VGG means reverse bias you apply to the JFET. So can I call this technique as, this biasing name as fixed bias. This biasing name as fixed bias we studied in the class. So first question will be completed very smoothly. What is ZIN? I think that the formula is RG parallel to infinite. Your RG is this one. RG is a 2 mega ohms. This is the first question. Input impedance is nothing but RG parallel to infinite. So it is 2 mega ohms. What is output impedance here? In the problem he has given R0, RT also. RT is nothing but R0 in our class. R0 or RT we call AC drain resistance is given as 20 kilo ohms. So if R0 is also given in the problem, I think your answer will be your RT parallel to RD will come. We'll have parallel combination. These two will come parallel. So RT is given as 2K parallel to 2K parallel to 20K. So what is this answer? Find out. What is the answer for that is? It's coming to be 20 by 11. It is coming to be 20 by 11 kilo ohms. See how much beautiful the questions. MOSFETs are very easy. Straightforward answers. So the first bit is completed. Your input impedance is 2 mega ohms for this bypass technique problems, and output impedance is 20 by 11 kilo ohms is the answer. 20 by 11 kilo ohms. I hope you are understanding this first question. Question number 1 is completed. This is your question number 1. This diagram is common for 3 questions actually. First question concept A. Next to question 2, if you go, question 2 is asking you, can you find what is ID? Can you find DC current ID? If you want DC current ID, Similarly, we have formula IDSS into 1 minus VGS divided by VP whole square. Correct? Already I told in the class, whenever you have a gate side, the current will become 0. This is VGS. So if current is not going, this resistor will be shorted. So only this battery will become the VGG. That is called fixed bias. So VGS will become minus VGG, which is equal to minus 2 volts. So this is called fixed bias methodology. VGG will become minus 2 volts. Then ID, you can solve it. Your ID can be solved as 10 milliamps is your IDSS into 1 minus 2 divided by pinch of voltage is minus 8 whole square. So answer is coming to be around, how much is coming? Answer is coming how much? Please solve this answer one time. 1 by 4 whole square. So it is coming to be around 5.625. Swati, you are telling correct answer. 5.625 milliamperes. Maybe your ID will come this much. 5.625 milliamps will come. Okay. Then VDS is asking next question. Same question, VDS in on. VDS. If you want this voltage VDS, it should be VDD minus ID into RD. VDD minus ID into RD. So VDD is 20 minus 5.625 milliamps into 2K. So just solve this answer. It's coming to be 8.75 volts. So option A will be the good answer for the second question. Option A is matching with the calculation. Second bit is also completed. One bit you are asking about the Jedi not problems. One bit you are asking DC concepts like IDQ, VDS, how much. DC problems you are asking. Okay. Next, what is the question number 3? Here only we can complete question 3 also in this diagram. Question 3 is asking about GM is asking. GM you know minus 2 IDSS divided by VP into 1 minus VGS by VP. This is the formula I created in no notes. If by chance if you forget it, no problem. Just to derive this answer with respect to VGS, you'll get the answer. It is minus 2 IDSS by VP, 1 minus VGS by VP. This answer, you have to solve it. I think it's coming to be around how much? 1.875 millisiemens. I'm expecting this answer. 1.875 millisiemens has to come for this. This is called GM calculation. After GM, he's asking what voltage gain. Voltage gain formula is minus GM into RD parallel to RD. This is your gain formula. Minus GM into RD parallel to RD. That is your bypass gain formula. So answer is minus 1.875 millisiemens into 2K parallel to 20K. So please calculate this answer. It's coming to be minus 3.41. These are your answers. So based on one question, they ask you 3 questions based on the single circuit. So maybe this is a good practice for you for single amplifier how to solve each and every parameter is asking. So we got a good confidence on this question now. Voltage gains, how to calculate, I got knowledge, GMs, DC voltage, DC currents, and input impedance, output impedance. That's a very good question. All the questions have been covered in the first questions. So 3 questions are completed. So 5th question, can you try it? Try karo, 5th question. Tell me 5th question is a bypass or unbypass? You should have the talent to answer the questions. Question 5. Try to see the question 5. See the question number 5. Meanwhile, take some water. Question 5 एक बार देखो. Question 5. Question 5. Try to see. Roy, I think I'm not identified fixed bias by RG. Use common sense here. Previous class में each and everything I explained you. So don't forget all these things here. This is a battery. This is a BGS. This two are directly connected because this is resistor will get shorted because IG is 0. This will get short. These two are same or not? This is called fixed biasing. Fixed bias इनसे नहीं है. Battery से fixed bias हो गया. Okay, right? It's not due to resistor. RG will be shorted everywhere. MOSFET का कोई भी biasing classes में RG will get shorted. That is not the meaning. You have taken a negative battery. That is called fixed biasing. We call. Okay? ऐसे भूल नहीं जाना यार. I'm doing this much hard work for you. Simply you are telling that. Question 5. He has given a capacitor. This is your input. It's a JFET I think he has given. JFET he has given with P channel he has given. Perhaps he has given P channel with RS resistance. This is 2 kilo ohms. This is 1 mega ohm. This is 6 kilo ohms. This is RD. This is your minus 20 volts. So by seeing this problem you can tell this is a common source unbypassed it is. Because RS is not equal to 0. This is a common source unbypassed question. Everybody has recognized? Very good. It's not bypass. Some students are telling bypass. It's unbypassed. Unbypassed means RS should be present. It's called unbypassed. Okay. Question number 5 is unbypassed. If it is unbypassed, what is the gain formula is asking? It's asking you, please calculate the closed loop gain of the amplifier. We know the formula standard minus GM into RD by 1 plus GM into RS. So with single step I have completed my answer. It is minus GM he has given already in the problem is 4000 micro ohm inverse, we call it as mho, divided by into RD is 6K divided by 1 plus 4000 micro reverse to ohm into RS. It is 2K. Just it's a formula based question. Straightforward, you are getting answer. शबनी दास वो भूल गया यार, एसी एनालिसिस में पूरा शॉर्ट हो जाएगा ना यार. Okay, if you keep capacitor, if you don't keep capacitor, short हो जाएगा ना. AC analysis we are doing, so I don't bother that capacitor because we're talking AC analysis. So why particularly you are saying capacitor should be there? तो क्या काम करेगा आपके लिए? It is minus 2.66 is coming. It is minus 2.66, but is asking magnitude answer. So answer is 2.66. So you'll get a very low gain using unbypass. Okay, you'll get a very low gain. Gain is coming very very less. Question number 6 if you see, same category again, same GM given in the problem. This is 5K. There is a capacitor, signal source. This is 2.5K. This is a capacitor. In AC analysis, battery you can neglect 5K. Capacitor will be short here, 5K. This is output. This will get short and this will get short. They're all shorted in AC analysis because we're talking about gains. AC analysis, when you do, capacitor should remove. It will be shorted in the class. So can I short this? If I short this, can I say this total part will become 0? So whenever it becomes 0, I got a knowledge that it's a common source bypass. You're talking about common source bypass because your RS became 0 here. This problem is concerned to RS is equal to 0. It's a bypass problem you're asking. What is the gain formula? It's a very simple formula. It is minus GM into, here two resistors are there parallel. So 5K parallel to 5K. So you can see problem is completed. So GM already given in this question also by himself, 2 milliampere per volt into 2.5K. So answer will be minus 5. Because just observing the circuit and finishing the problems. That is the beautiness of these concepts. Question number 6 is minus 5 will be the answer. If you want in magnitude, answer will be 5 you can take. I'm expecting this question is also simple only. Next common data question we'll do, question number 7 and 8. Next we'll do the question 7 and 8 will be the next two questions. 5 will be the correct answer, boss. Correct. 5 is the correct answer. So one question is based on unbypass, one question is based on bypass. You can see side by side, two questions. If it's unbypass, my formula is different. If it's a bypass, my formula is different. The gain is coming more for bypass system, the gain will come less for unbypass systems. So question number 7 and 8 are easy questions again. Question 7 and 8 if you see, they have given some diagrams actually, like this. 2 millivolts, make it ground, DC को ground कर दीजिए. We have some 10K and make it ground. This is your output. Just AC representation I have done. If this model is AC, side by here is going to graph also, experimental graphs like this, saying that this is 1, this is 2, this is 3, this is 1, this is 2, this is 3, SID. This is VGS. Suppose somebody asks you the question, please calculate question number 7. GM is how much? So GM can you take from graph or from circuit? Either say calculate cut out. GM you want to solve it. Whether you solve from the graph or you solve from the circuit means GM formula is the change in the current divided by change in the voltage VGS. This is GM. If you see here the change everywhere, 1 milliampere is changing, here 1 volt is changing. So if you take this change, suppose 3 minus 2 divided by 3 minus 2, we have the same change. So this will be milliamps, this will be volts. So it is coming to be 1 milliampere per volt. So the change is coming to be 1 milliampere per volt. 1 milliampere per volt, which can also be represented as 1 millisiemens, which is calculated from graph easily. So that is the reason they are given graph for it. GM easily you can solve for graph. Having a resistance in series won't affect the voltage gain. Yes, Partha, what you said is correct. Okay, series resistance whenever they give in MOSFET classes, the current is 0, so it will not impact your circuit. Okay, only this impact you are getting the concept of current gain calculation. So in case of BJTs, we have RS effect will be there. Here we don't have problem, but there is one issue going here is maybe gate is open you said, but if you have RS like this is RS. But if you have some RT resistance here, then impact will be there because the current can go this side. Maybe the current will be 0 this side. RT is there here, so impact will be there RS. Only thing is the current cannot go this side, but current can go to RT resistance or not. Definitely the formula will be valid here also. That's called voltage gain analysis. Next come to question number 8. Question number 8. What is the 8th question you are asking is the voltage gain of the amplifier. It's a bypass amplifier, so it is minus GM into RT. It's a bypass formula. It's a bypass question. It's a bypass question. So answer will be GM is 1 millisiemens with minus into RT is 10K. So answer is minus 10. The gain is coming to be minus 10 will be the answer. Just a load I multiplied with GM, we got the answer. So up to here 8 questions are smoothly completed. Next to question number 9 we have to understand now this question. It's a GATE 2013 question. Let us understand how to solve this problem. Question number 9. Try to analyze the problem meanwhile. Question number 9. What is asking? Try to understand it. Question number 9 is asking you small signal resistance. Derivative of VB by derivative of ID is asking. So let us understand the question. Question number 9. He has got a MOSFET like this and he connected to VB and he made a short like this and saying that this current is your ID. So whenever you see like this, every student knows that in our class, it's a current saturation. It's not required to repeat number of times this story. Whenever there is a short like that, the circuit works under the biasing of current saturation. Because in current mirrors we have seen, in your inverters I have shown you so many times, we are developing this concept. So what is my meaning here is, Whatever VGS you have here, your VDS, both are same, natural. These two answers are same. So VGS and VDS is same, which is VB, he said in the class. Because this voltage is VB and this voltage is also VB. So this is the first point I understood. And this MOSFET is in current saturation. MOSFET is in current saturation. If the MOSFET is in current saturation, what is your ID relation is? Half into nu n Cox W by L into VGS minus VT whole square. This is your ID equation. But now in the class, VGS is same as VDS, VDS same as VB. So you can write the formula half into nu n Cox W by L VB minus VT whole square you can write. Now what he's asking is, he's asking you, if I differentiate ID to VB first and I write that answer reverse, that will be your calculation, small signal resistance. So just to differentiate this answer, differentiate with respect to VB curve, differentiate with respect to VB. Then derivative of ID by derivative of VB. First you solve this, it becomes 2 into half into nu n Cox W by L into VB minus VT. So first finish that value. VB has given us 2 volts in the problem. So I think he wants a reverse answer for this. So this is a 1 by RT actually. So if you want RT here, small signal AC resistance. Okay. If you want RT reverse answer, it is, you can reverse it dVB by ID. So it is reverse answer 1 by nu n Cox W by L into VB minus VT. So I think if you solve this, you will get the small signal resistance. Just this is the way how to do these questions. Simple basic questions there. Nu n Cox W by L 1 by 40 microampere per volt square. This is the data given. And VB is going to minus 1. 2 minus 1. Neglecting channel length effect. So answer is coming to be around Bose 25 kilo ohms. 25 kilo ohms is the correct answer. So this is where you can solve that gate question. Okay, this completes the 9th question in the problem. 9th question is completed. So 10th question is actually a tomorrow class concept, but you have the knowledge of active load concept. So with the help of active load, I can solve this problem. Let us understand. With the help of active load, how can I finish this problem? Tomorrow class का problem आज complete कर सकते हो. Let's see the trick how we'll apply for this problem. This is called cascode problem. Tomorrow will be the class. No problem. Today we can do it with our basic knowledge. So question number 10 you can see. Question number 10. In this question, he has taken 2 MOSFETs. Gate to source. This is V bias. And he has given the drain like this. This is M2. This is M1. Circuit is used as an amplifier with input connected between gate and source. He has given some input here. From here to here. There is a AC input here. Now he said that, can you tell me what is the GM first answer? Seeing the board, what is GM? The overall GM of the circuit is asking. GM means what actually? Output current. This is output current divided by input voltage is GM. So output current is I0. Input voltage is VIN. This is GM of the total circuit. But it can also be written as the same current. Can I take here same? Because no gate current will be there. In MOSFET, no gate current. So this current will go in series like this. Now what is the GM? This is the GM of your cascode actually. Total system is cascode circuit. This overall cascode circuit GM is same as your GM1 of the first transistor. You can see I0 by VI is same as I0 by VI. So GM of the overall circuit is coming as GM1 of the first transistor. So that is the first option I am seeing. GM is equal to GM1. Maybe in C and D options we have. What about the second option here is, when you are solving here, when you are solving from here the output impedance, can I have a trick here? This V bias will make it ground for AC analysis. This also will become ground for output impedance calculations. This is your drain. They are asking me, calculate here some Rx. Active load resistance I am solving. V bias is ground when you do AC analysis for active load techniques. And input signal also should be grounded because you are finding output resistance. So AB ground हो गया, AB ground हो गया. Because you are solving the output resistance from this circuit. इधर से calculate कर रहे हैं, that's a signal को भी ground किया है. Now the point is, from yesterday class we have the trick here. This is your drain point. Suppose if I want to know what is this Rx1 value, so that I can replace this total transistor with my active load equivalent circuit. So what is this answer we can write? You are saying from drain, so answer will be simply, this is M2, this is M1. So simply we can write this as, from the drain whenever you see it is R01. From the drain it is R0, R01 will come. So this model, again we can write like this. This becomes R01 and this is your drain. So if you see the Rx value, it is just looking like our previous topic called common source unbypass technique. I said one beautiful technique for this. You have some R02 here, we have some GM here, this is open. This trick you can apply to solve the Rx. A beautiful trick is R02 plus R01, R02 plus R01 plus GM into the two resistors product. So Rx can be written as simply R02 plus R01 plus GM into R01 into R02. Can you see how much these formulas are helping me to write the answers without doing any derivations? At that time I said this is a golden trick for us in analog electronics, which saves more time for me to answer these questions. Just I replaced it to make it as an unbypass and the trick is completed. In the options I think approximately is telling, so he neglected it. Maybe this answer he has taken. The answer approximately is telling this answer, GM1 into GM, what GM it is? GM2, second transistor. GM2, R01, R02 will be the answer for it. So like this you can solve this type of question. It's a GATE 2018 EC students ka question hai. These are all coming for tomorrow classes called cascode system techniques. In multi-stage electronics, I'm going to teach these ideas. Maybe today only you can get this idea. how the answers will be. Just with the help of active load, I completed. Here V bias is 0, and here VIN also should be 0 to calculate the output impedance. Okay, so please complete this question. 10th question is completed. 11th, can you write it also active load problem? 11th question, you can write. Simply seeing the diagram, you have to understand the active load concept for it. Straightforward, we can write the answer for 11th one. It is also latest GATE 2016 question. We are coming close to the problems, please complete it. By 4 o'clock, we will close the matter. So 11th question I am doing. Question number 11, if you see, I want the equivalent model for this. This is M1. In that we have load here, we kept a load with 2 transistors. We kept a 2 transistors. Sorry, here he has taken P and P. Be careful here, correctly how to do it. This is P and P has taken. This will be ground, VG will be grounded. AC analysis we are doing, so this will be ground. This is M3, this is M2, this is M1. You have taken some output here. I said one trick for you, the trick please apply. Can I take now R0 C has given for every problem, options me. So shall we write R0 positions? For this you will have some R0. It will have some R0 inside. And here from where you are seeing is, from source we are seeing here, please remember the point. Here from drain you are seeing here. So then what is your Rx value here is Rx3. You take this answer as Rx2. This as Rx1. So total 3 actions are there. If you see from the drain, what is the answer I said previous class? Whenever you see from the drain point, the equivalent resistance, very simple answer, it is R02. It is R02. From the drain, answer is R02. If you see from the source, the answer is, in the options he has given, 1 by GM. 1 by GM2 parallel to R02. These are the tricks I told in the class. Without doing anything, straightforward answer you can say. So this is R01, this is R0, Rx2, this is Rx3, this is Rx1. Your all answers should be parallel, that is the answer for it. So gain will be equal to minus GM1. This is the gain from the coming signal transistor is into Rx1 parallel to, this total will become parallel. Rx2 parallel to Rx3. So this should be the answer. So minus GM1. Your Rx1 here is R01. Next to parallel to this one, 1 by GM2 parallel to R02 parallel to simply R03. So this much lengthy answer I completed only by seeing the circuit. That is the way how analog electronics we have to develop. Okay. If you don't have this much knowledge or tricks, you have to analyze this complete amplifier model. I think your gate exam will be over. Also, you'll get confused what is the answer for that. Who will have the shortcut tricks like this? You just write the answer straightforward. It's a bypass amplifier technique. Single step, the answer is completed. Rahman, I think question number 10 का answer क्या है? Question number 10 का answer क्या है? This is the answer. This is the answer. GM will become GM1. GM will become GM1. Yeah, GM1 will become, here Rx approximately will become GM2, R01, R02. That will be the answer for it. Maybe option C is correct for that. So please complete this one, 11th question. So 11th question is completed. We have 12th, 13th, 14th, 15th, total 4 questions are there. 12th question is a theory question here, is asking, in a CMOS common source amplifier, the active load is obtained by connecting. So active load is coming by what? Is asking. It's a P channel current mirror circuit, N channel transistor, P channel transistor, BJT current mirror. CMOS में active load कैसे आएगा? By using which transistor is becoming your active load is asking. It's a PMOS or NMOS is asking. PMOS or NMOS. P channel transistor, N channel transistor it is. Okay. Below you are taking as an amplifier. Above is also we connected as a load. That is called PMOS. We connected as a load. So 12th one I am expecting it should be a P channel transistor will come as a load for active load. So that 12th question you can say C is the correct answer because CMOS. If you see 12th question, CMOS we have designed like this. CMOS design is like this. It's a pair of 2 MOS transistors, NMOS and PMOS. Active load is obtained by connecting A. It's asking you active load. Current mirror I have not used, my friend. Here we are not using any current mirror. Here active load. We can take this one as active load. It's coming by P channel transistor. It's coming by P channel transistor. Okay. For CMOS that will become the active load for you. So coming to the 13th question. Question number 13. Question number 13. He has taken here RT as 10 kilo ohms. Capacitor C is equal to 1 microfarad. Resistor RL is equal to 10 kilo ohms. He is asking you the lower cutoff frequency will be how much? He is asking FL how much? So you already know the trick I think. It is 1 by 2 pi that C into R equivalent we are right. What is the trick I told you? R equivalent trick. When you are seeing from here, what is R equivalent? These two should be series or parallel. You have to take. BJT what we studied, same methodology. So active loads के लिए current mirrors use कर सकते हैं, but in CMOS we are not using that one technique like that. Okay? Our technique is P channel transistor we are using as an active load reactor. Generally active loads can be used with P bias, correct? P bias will come from the current mirrors. But in this question is asking what is your active load? PMOS or NMOS is asking. Bottom is my amplifier. Above is the load I kept. That's a P channel I have written. So this formula is known. RT plus RL will be the calculation. So this formula came from BJT classes. So the lower cutoff frequency is how much? So it is 1 by 2 into 3.14 into C value is 1 microfarad into RT is 10K plus 10K. It is coming to be around 8 Hz is coming. 8 Hz. These formulas are very important to solve it. Should not take parallel. Majinder, भूल गया then. हाँ? मैं क्या बोल रहा हूँ भूल गया. Short notes भी दे रहा हूँ. Okay? Revise करो यार एक बार. Mistake बता रहे हो आप मजिंदर. कैसे बताते हैं ऐसे? BJT class में भी किया ये problem. Again we are doing in MOSFETs. They never be parallel here. There will be series always. This is the trick I told you. Okay? This is the trick we have to keep in mind. BJT class में भी किया है problems. Question number 14 if you see. Question number 14. The drain gate capacitance of the junction. If you see like this. This is the MOSFET. This is a drain, this gate, this source. He said that there is a capacitance between gate to drain. Drain gate capacitance is 2 picofarads. And he is asking you, what is the input capacitance by Miller effect? Can you answer this question from BJT knowledge? Somewhere I taught you this class in previous lecture. Miller's effect. He is asking you what is CIN from the MOSFET. He has given gate to drain capacitance. And my formula, you know, shortcut method. It is, if you take this as CDG, it's a CDG into 1 minus AV. This is called Miller's effect. 1 minus AV will come. Therefore, gain he has given in the problem is common source means gain is a negative gain it is. So you can write CDG into 1 minus of minus 20. In the problem he has given only 20 but you have to take minus 20 because it's a common source amplifier. Common source you cannot take plus 20, you have to take minus 20. So CGD is 2 picofarads, it will be 1 plus 20. So this is called Miller's capacitor technique problems. So what is the answer for 14th question? What is the answer for 14th question? What is the answer for 14th question? It is coming to be 42 picofarads. 42 picofarads will be the answer. So 15th question generally will come tomorrow class, that question. Okay. If you want, I can give straightforward formula for that, which is called rise time. Some problems will be there. You can just tell you the formula. With that you can solve it. Tomorrow I'll try to explain why that formula is coming. Tomorrow I'll explain. It's a rise time problems we call. TR means rise time we call. Tomorrow class this derivation also there for me to teach. Rise time is equal to 0.35 divided by bandwidth. This is a very standard relation in analog electronics in multi-stage techniques we have to study. Rise time formula is 0.35 by bandwidth. Tomorrow classes we have some standard formulas related to that. We have to understand the conclusions. Tomorrow class is multi-stage techniques. If you want to teach op amps, first you have to touch the multi-stage. After that you have to go for differential amplifiers. So tomorrow class my schedule will be morning class is multi-stage I'll explain. Afternoon class is differential amplifiers. Tomorrow we are completing 2 modules. Okay. And day after tomorrow onwards op amps will start. Okay. Op amps start करने के लिए first these 2 modules we have to cover. So rise time is equal to 0.35 by bandwidth. That is the formula. Just you can find out with this formula. Question 15 for our ECA is not there in electrical workbook sir. Okay, no problem here. If it is not there, you solve in an electrical book. What is there? उनमें ले होते हैं. इधर solve कर दीजिए. 0.35 by 500 kilohertz. According to the formula, I am doing it today. 0.7 microseconds will be the answer. So this is the formula for this one. Question number 16 if you see. Question number 16. It is an active load problem is asking. Correctly see. Above is an active load, below is an amplifier. What is asking is W by L1 by W by L2 is asking. Okay. Whenever the question is like this, the only style I know is the gain formula for active load is minus GM1 into 1 by GM2 should be the answer. According to this problem, below is GM1 into load, above is a diode connected MOSFET will have 1 by GM. So the formula is minus GM1 into load, that load is 1 by GM2. I have written straightforward. You know active load answer is for diode connected transistor it is 1 by GM. So this is my problem. So can I write the statement? He has given in magnitude I think. It should be unity gain inverting amplifier is asking. So this answer should be minus 1 he want, inverting amplifier. Inverting amplifier. Unity means minus 1 he want to make. So this answer will be minus GM formula. If you want GM formula, what is the formula for GM in what I can say? In terms of ID structure, if you write, it is 2 times ID into UN Cox W by L1 divided by, it is 2 ID nu P Cox W by L2. So this is my GM formula I have written in terms of ID structure. So this minus will cancel. This 2 will cancel. ID will cancel. Cox will cancel. But something will not cancel is mobility of electron source W by ratios. So you can write it as nu P into W by L2 is equal to nu N W by L1. So like this NMOS PMOS can be balanced with mobility ratios to your with ratios to become phase shifters. So he's asking the ratio here, the ratio of W by L1 by W by L2. It is equal to nu P by nu N. Just solve this answer, you'll get the value. How much it is? Nu P is 325 and nu N is 1300. So how much it is coming? Just solve it. Question number 16 it is. Question number 16. So answer is Sneha Kumari. Both confused हो गया 4 नहीं है. 0.25 will be the correct answer. Because 325 by 1300 it is. Okay. It will become 1 by 0.25 will be the correct answer for it. Is it okay? How simple the questions you can see. Only thing is GM structures with respect to ID formula you should practice. Straightforward you can recollect and we can solve the problems. Question number 17 I'm doing. Question number 17. In this, he has given a signal with 50k. Then we have MOSFET with 5k minus 5 volts. This is 5 volts. Say 6.7k capacitor to the 10k. This is your output. This is a circuit he has given. He is asking you across CC. This is CC. Across CC, FL he has given already in the problem is 20 Hz. So this problem already we done it. So FL is equal to 1 by 2 pi CC into this you take RT, this you take RL. RT plus RL. This problem is again repeated with this idea. CC is asking now FL is given. So try to solve this problem. CC is equal to 1 by 2 pi FL RT plus RL. Solve this problem. FL is how much? 20. Your RT is 6.7k. 10k. CC find out how much it is. CC how much? Please try to solve it. CC how much? We have only 20 minutes time now. We'll finish off. By 4 o'clock, I close the matter today. You have a 1 hour break. Okay? Happy you can take break for 1 hour. 5 o'clock, your networks teacher, sir will come. Try to start your class with networks. Who has completed networks, if they cannot, okay, you can take rest and you can study then work. Remaining students, who is new to the networks, you start, okay, developing the networks from this today class onwards. The class, I think I told you, 5 to 8:30 something, sir will take class 5 to 8:30 at 9. So try to make it parallel subjects. So the CC value is coming to be how much? Anupam Das 4.765. Anupam Das 4.4765. Okay, correct. 0.476 microfarads. So 0.476 microfarad is coming. Yeah, 0.47 microfarads you can take. Okay, but this is correct answer. If you see the question number 18, correctly if you observe question number 18, he has given, you can see here, below he has given some 10k and 20k, which is at collector point. And he has given one capacitance also here, that is 10 picofarads, just here. He is asking you, please can you calculate FH. He is talking about higher cutoff frequency. Seeing from the collector point, what is the higher cutoff frequency? It's very easy. These two are parallel, this capacitance. So FH you can write as 1 by 2 pi CL. CL is the extra capacitance given, which is the internal capacitance. They will take like that, 10 picofarads he has given. It's not external, it's internal capacitance. Okay? And into this parallel combination will be the R equivalent. So 10k parallel to 20k. So this is not lower, this is a higher cutoff frequency is asking. Sir, how you know this higher means megahertz is telling in the problem. Megahertz means higher cutoff frequency. Whenever higher comes, they will look parallel for you. Okay? The resultant will look parallel. Radha, I think if you have got the recording video of that faculty networks, okay, it is not required to listen. Who is not getting anything, that people will listen it. Okay? If you have recording video with you, nicely you can complete the task. Already you have covered, I think. Okay? For that people I am not telling. Who has not listened, some students are there in this batch. For that students they kept network theory. Okay? Who has completed, they can take rest, no problem. They can leave and they can study this subjects, you can revise all these things. The students who are fresh to listen networks, they will listen it. FH value will be how much? So Majumdar, वर्कबुक में देखो क्वेश्चन करेक्टली देखो वर्कबुक में the value of 3 dB corner frequency in megahertz due to capacitor CL. Megahertz is talking. Megahertz means what? Higher cutoff frequency. Like that I understood it. Okay? Megahertz is asking. He said this word megahertz. Find out the answer in megahertz. Then it will become the higher cutoff frequency. How much this answer is coming? It's coming to be around 2.3 megahertz. We're getting around 2.3 megahertz. Yes, Samresh, networks are, who is that? Naresh sir will take the class. Naresh sir only taking networks. I think some people are getting recording video of Naresh sir only. I'm expecting. That faculty only is going to take. So around 2.3 megahertz. So we have 15 minutes time. We'll finish off remaining questions. We came very close. So 19th question, you can see. Question number 19. We're coming very close to the problem. See here. So he's asking you the small signal input pole frequency is how much. He has given like this here. This is 5k. This is MOSFET. This is 1k. This is VDD. There is a capacitance here. Given is 50 picofarads. He's asking pole frequency at the input means lower cutoff frequency you want. So I can write a model here. We'll get here 5k. If I write AC model, you apply Miller's effect here. Miller's effect. Therefore, the capacitance will come here as CIN, Miller's capacitance, which is equal to 50 picofarads into 1 plus AV in modulus you write. Miller's effect I applied. AV, I think, this answer here, fine. 1 plus AV. AV means we can write GM into RD. You can solve it. 50 picofarads into 1 plus GM. GM given is 0.1 Siemens. This is 0.01 Siemens into load is 1k. So find out the CIN, and I think if you want to find the FL for this, the answer is 1 by 2 pi R into C. R is 5k, C is CIN. So with this you can finish this problem. So CIN find out terror first, Miller's effect, then R will come, C will come, find out that answer. Remaining, this is open circuit. So we don't have anything here. MOSFET is under open condition. So what is this answer? FL value how much? So coming, if you solve this answer, we got here 57.87 kilohertz. Please try to solve and see this answer. Approximate calculation value I am giving for it. 57.87 kilohertz. ये आंसर कितना एक बार देखो CIN. Please try to solve it. CIN value. From that this answer you can find. It is coming to be some 57.87 kilohertz. 87 kilohertz is coming. So try to answer this question how much. With this हो गया T1 हो गया, T2 is completed. T3 and T5 two questions are there. T3 question. T3 question is unbypassed question. It is unbypassed. Is asking small signal voltage gain. It's a common source unbypassed. Straightforward seeing the problem is unbypassed. The gain formula is minus Gm into RT by 1 plus Gm into RS. So apply this formula and solve it. So if you want the Gm, IDQ given in the problem, so Gm formula we can solve by under root of 2 ID into nu n C ox W by L. So using this formula you find Gm first. Gm find out करने के बाद problem solve हो जाएगा. So what is the gain formula for this? If you solve it, the gain will come approximately for this minus 5.80 I can expect. Minus 5.80. Shabanidas, एक point use करो thinking. Whenever a contact is like this, I'm already telling so many times to you. This is input here, this is output here. Middle में कोई भी capacitance आते हैं. We cannot do the problem conveniently. Millers means what? It's not Miller. Miller is nothing but a feedback. You're seeing here feedback or not? Previous problem में T2 question of BJT में भी देखा मैं. So wherever you see that such type of question, such a type of problem, you have to just resolve it. Then only the problem looks convenient to solve it. Examiner will not tell you a Miller's theorem cut करो ऐसे नहीं बोलते. हम practice session we have to do in such a manner. Whenever you see collector to base or drain to gate any contact, it may be a resistance, it may be a capacitance, it may be inductor also. In future advanced topics, you have to just cut it into two parts by using the knowledge called Miller's effect. Okay? Unnecessarily don't think एक use करना. ये question क्या है? Number of times you are using it, you must get a hobby on that. It's a shunt feedback we call. In any shunt feedbacks, when you have a contact like that in the middle, just to throw the Miller's effect always. Okay? Miller's theorem use करना. How will know? Don't say like that. How will know? Because there is a feedback here. That's why Miller's theorem apply किया. So coming to the last problem here, the final question of today class. Happily I completed all issues today. Very happy that syllabus is going perfect today. Perfectly I completed. This is ground. This is your input. This is your resistor or this is VDD. I'm giving a chance for you. Can you solve it? Already you became expert in Acculo techniques. So for this question, how will you deal? Finish off this answer. A question कर सकते हैं आप. Straightforward answer निकाल सकते हैं आप. Samresh ID he has given you the problem. Correctly देखो. वो डेटा में नहीं दिया, सर्किट में दिया. करेक्टली देखो. IDQ 0.5 milliamps given in the circuit. सर्किट में दिया. करेक्टली देखो. IDQ in the circuit he has given as 0.5 milliamps, not in the data. You are seeing only data, not seeing the circuit. So I think this problem is a very silly problem from our theory concept. This is your active load. This is your source, my friend. So we have here 1 by Gm from the source, and this is second transistor, I think. So Gm2. This is M2. This is M1. So I can write this equivalent model as simply equivalent resistance 1 by Gm2. You can write. This will be VDD. This will be R. This will be output. This is input. How it is looking for you? This model, how it is looking for you? It's looking like a common source unbypassed, correct? You can see how much comfortably we are doing problems. It's a common source unbypassed. So common source unbypassed gain, if you want, AZ is equal to minus Gm1. Where is your Gm1 here? Gm1 into R divided by 1 plus Gm1 into 1 by Gm2. This is the way I am getting formula. So according to the options, if you see, we can write it as minus R by 1 by Gm1 plus 1 by Gm2. So I think option A will be the correct answer for it. Majumdar option D बोल रहे हैं आप. Option A will be the correct answer for it. Option D किधर से है आप? This is from the source we are seeing. So 1 by Gm2 I have written. Source से हमको low impedance मिलता है always 1 by Gm2. Correct? So style is completed. The formula, background formula is, the background formula for this is minus Gm into RT by 1 plus Gm into R. Yes. This is the formula. According to the board, this is RT, this is RS. This is RT and RS. Okay? So previous slide, 70 you're asking previous slide. This is the previous slide. What is that? EC workbook question 15. Question 15. Sahu is telling question 15. Is a new question, is there? What is the new question? Question 15. This question is related to current mirrors here. Okay. Easily you can do it. Current mirrors मालूम है आपको? Try to solve it. This question. Question 15 is one new question for electrical. EC. I think remaining questions are similar. I think one question I have seen. Question number 15. This question I'll give a chance for you. You do it. Question number 15. Okay. In your WhatsApp group if you want. I'll try to post this answer for you. Just solve this one question at least. You do it one question. Okay. All the questions you don't make me to do it. At least one question you have to do it. वो क्या किया वो? Input he has given for the bottom transistor. I'll use the logic. Try to solve it. Input he has given to the bottom transistor. He's asking what the gain of the circuit is. Simple question here. The gain of the circuit is how much he's asking. The bottom transistor is your Gm1 of your first transistor. Above is completely load for you. Above is load. If you want that load, they kept the current mirrors on the other side. That current mirrors will bias your active load. Correct? So how much this current mirror will send the current to the other side, and how much the equivalent resistance you can draw for that. This is the question actual. A question चाहिए तो आपको I can post this question for you. Solution. So there's only one question I can send for you in WhatsApp. You can see the solution, or I'll upload in the in your PDF format. This question I can upload it. So this one question, please solve it yourself. Question number 18 you want. Question number 18. Question number 18 is this one. And if you have a gate books with you, 2019 question A 2 marks दिया. It's a easy book. You can refer the solution also if you want. In your gate books you can get it. Question number 15 में वो solution मिलेगा. आपको समझ में आता है question because it's a only simple current mirror question. You try to solve that question. Yeah, boss is telling the answer is 900 for that. Yes, for that question 900 has to come. Try to solve it. It is question number. Just I'll give the hint for you. It's an easy book. Easy. Question number 15. Question number 15. Page number 60. Page number 60. You try it yourself today. The answer has to come. The gain of the circuit has to come. So I don't know that answer. I have not done it. Maybe boss is telling 900. Maybe I remember that has to come 900. Otherwise tomorrow I'll confirm that answer for you. Rounded off to one decimal place. Just you try to solve it. 1 minute. Let's see that option for that question. How much it is? Just to solve that question. I'll give the answer for it. So I think I refer that this answer has to come as minus 900 has to come here. This problem answer should come as minus 900 has to come. Just I'll give a rough discussion about this and see. Basic thinking I'll develop for you. You can do it yourself. You have a short here. This problem I'm expecting every student can do it. It's not a big issue. This is VIN. This is V out. This is 4 volts. Correctly if you observe, this is the circuit given. So amplifier, you are giving signal here. Okay, you are giving signal here. You are getting some amplified output lines here. That means your transistor here, if you take some name, this is M1, this is M2, this is M3, this is M4. You have 4 transistors. I want to know this gain how much. The gain formula is simple. The gain is equal to minus GM1 of this transistor. It's a bypass transistor into load. Load is nothing but this is my load. This is my load. If you see from here, the load, which is from where you are seeing, this is a PNP or this is a PMOS, sorry. PMOS. PMOS means what? This is source, this is drain. This will become R0. Okay, from the drain it is R0. And this also you have R0 inside for this also. So we have 2 R0s are there. Top side 1 R0, bottom side 1 R0. Because one is NMOS, one is PMOS. So both will have R0s. Therefore, R01, R02. You can write R01 parallel to R02. Up to here, this is the story actually. But GM1, if you want to solve, your formula should be root over 2ID into nu n Cox W by L is required. That means ID is required. You must know ID in the class. How to get ID? This is 2 identical MOSFETs he has given. So this is 4 volts. So can I say this is 2 and this is 2. Total 4 volts will be divided into 2 bars. If you have this 2, I think one current you can find from one MOS transistor by taking that both are in current saturation. It's 2 are in current saturation, so you can find out ID with the help of that half into nu n Cox W by L PSG minus VT whole square. With PMOS you can find out that relation. You will get some current here. Whatever the current you got here is a current mirror, so it will reflect here current. Same current will reflect there, correct? So find out that current आने के बाद GM1 find out करो. R01 parallel to R02 if you do it, problem is solved. Each R not given in the problem is 6 mega ohms given in the problem. 6 mega ohms is given. So you do it, this problem आप कर सकते हैं. The answer I think minus 900 has to come for this question. Answer should come as minus 900. Okay? So that is the concept here. So somebody is asking last screen. This is the last screen for you. With this we have been successfully covered the total issues of MOSFET and BJT amplifiers. We have nearly completed 70% of the course. Only 30% is remaining, which we are working for 5 days. Within 5 days we will cover the remaining 3 chapters. One is multi-stage amplifiers and one more we have is operational amplifiers. Last chapter we have is oscillators and feedback amplifiers. Maybe 4 chapters are there. These 4 chapters will complete in the 5 days module. Daily 2 modules will be completed. Tomorrow module is multi-stage in the morning. Afternoon we complete the differential amplifiers. Okay? Tomorrow is the schedule. Today 4 o'clock only we completed successfully. Correct? So we'll take leave. So tomorrow we'll meet again. Again the timing will start at 8:30 tomorrow. Tomorrow also I'll start at 8:30. 8:30 tomorrow to 4:30. Tomorrow timing analog is same. Networks will start at 5.